We're going to take a look at the following. R of t is 3 cos t, 3 sine t, 4t. It is a helix, and we are going to do some analysis on the unit tangent vectors. So let's remind ourselves the velocity is going to be tangent, and the velocity is simply the derivative of the position function. So the velocity here would be negative 3 sine t, 3 cos t, and 4. So that's my velocity function. Now, the unit tangent vector is a vector with length 1 that is parallel to the velocity. So what will that be? How do I make the velocity have length 1 pointing in the same direction? I turn it into a unit vector by taking the velocity vector and dividing by its length. So I need to figure out what the length of v is. And what's our process for getting the length of a vector? We use the dot product. So what is v of t dot v of t? So negative 3 sine t times negative 3 sine t, which would be 9 sine squared t, plus 3 cos t times 3 cos t, which is 9 cos squared t, plus 4 times 4, which is 16. So what do we get here for v of t dot v of t? 9 sine squared plus 9 cos squared. Let's factor out that 9. We recognize sine squared t plus cos squared t is equal to 1. So I get v of t dot v of t is 9 times 1 plus 16. V of t dot v of t is 25. So then what is the length of v? Remember that v dot v is the length of v squared. So the length of v would be the square root of v dot v. If that's the case, then the length of v is the square root of 25, which is just 5. So that enables us to then figure out what t of t is. T of t is velocity divided by speed. So here's our relevant information. R of t, our position function, v of t, our velocity, and magnitude of v of t, which is our speed. The unit tangent vector is in the same direction as the velocity, but it has length 1. The unit tangent vector is simply v of t divided by the speed, divided by the magnitude of v of t. So what is that? Negative 3 sine t, 3 cos t, 4, all divided by 5. So what are we going to say? We're going to say t of t is negative 3/5 sine t, 3/5 cos t, and 4/5. So let's take a look at the graph of this, and let's think about what we think t is going to be for various values. So here's our helix. Notice how I have it programmed. X of t is 3 cos t, y of t is 3 sine t, z of t is 4t. I'm going from 0 to 6.28, so about 2 pi. Obviously, 4 times 6 is 24, so that's beyond our frame here, which is going up to 16. And this is what our helix looks like. So can we see the starting point? It's not quite at the origin. Now, why is that? If we look at the starting point, if t is 0, cosine of 0 is 1. So x is 3, y is 0, z is 0. So that's your starting point there. So what do we expect the unit tangent vector for that to be at that value? Also, if we just look at the 2D representation, if I look at the top view of this, so ignoring z, so if x is 3 cos t and y is 3 sine t, what will that graph be? The 2-dimension gives us this. So the helix top view is a circle. But here we go, looking at it from this perspective, you'll notice as it's wrapping around the circle, it's growing in that z direction. And that's our helix for one full turn from 0 to 2 pi. Again, 2 dimensions here, 3 dimensions here. So what about t of 0? What do we expect t of 0 to be? It's got to be a vector of length 1 in the direction of the velocity. But I have my formula here, so let's take a look. What will t of 0 be? Negative 3/5 times sine of 0, that's 0. 3/5 times cos of 0, cos of 0 is 1, so that's 3/5. And 4/5 in this slot. And where's my starting point? What's r of 0? So that's the direction vector of the unit tangent. R of 0, 3 times cos of 0 is 3. 3 times sine of 0 is 0. And 4 times 0 is 0. So let's take a look at this unit tangent vector at the point where r is 0. Let me show you how this works on this system. I'm going to add a vector. And that vector is 0, 3/5, 4/5. See if I can handle back fractions. 0, 3/5, 4/5. Let's go ahead and make it red. And our starting point is 3, 0, 0. So can we see that? Do we see that vector? May require us to zoom it in a little bit. So as we zoom it in, you can see that vector of length 1 heading in the direction of the curve at time 0, when little t is 0. Let's go ahead and try one more. So how about pi over 2? So that's negative 3/5 sine of pi over 2. Well, sine of pi over 2 is 1, so that'd be negative 3/5. 3/5 cos t, cos of pi over 2 is 0, so that's 0. And then it's 4/5 is there. Where's my starting point? What is r of pi over 2? Plugging pi over 2 into the original. 3 times cosine of pi over 2. Cosine of pi over 2 is 0, so that's 0. 3 times sine pi over 2, that would be 3. 4 times pi over 2. 4 times pi over 2 is what? Is 2 pi. So let's go ahead and draw those vectors in and see what that unit tangent vector looks like. So we're going to add another vector. And the vector this time is negative 3/5, 0, 4/5. Negative 3/5, 0, 4/5. And we can make the color this time. Let's make it blue, maybe. And the initial point is 0, 3, 2 pi. 0, 3, 2 pi. I'm just going to go with 6.28 for 2 pi. And see if we can see that. So I may need to zoom this thing out so I can find it. And sure enough, there it is. So we see that little blue vector going in the direction of that helix, starting at that point 2 pi. Check it at 0, 3, 2 pi, going in the direction of the helix with length 1. So for any value t, I can find the unit tangent vector. Yes. Again, what is t of t? T of t is the velocity divided by the speed. So the only time this would be a problem, of course, is if the velocity vector is 0. Because if the speed is 0, the magnitude of the 0 vector is 0. If you have a velocity vector, a 0 vector divided by 0, you're not going to have any kind of a sensible unit tangent vector. But the thing to remember, of course, is that the magnitude of the unit tangent vector for all values of t is 1. Yes, we get it by taking velocity divided by speed, but the result for all values of t is 1.